Good afternoon. This is Lee Cassidy from Tactile Technology, and it's our regular Diamanti Monday. But this time, hopefully, we're actually on LinkedIn Live as well. Need to check to make sure it's actually going out actively afterwards. If not, what might do is redo it directly on LinkedIn Live. But we've been waiting quite a few months to get our approval through, which came through last week while I was away on holiday. So I've had a couple of weeks refreshment. We've also had quite a few reruns of some of our technology over that time. So we reran some of the videos from our Diamanti Mondays earlier in the month. And also, we've done some tin tree ones, including ones around Mark Young, who was one of the first people I'd interviewed on a video about 6 or 7 years ago, and they went down really well because no one's seen him for such a long time. It's really good. But anyway, let's get back down to Diamante Monday. It's an interesting day today because it's, like I'm saying, my first day back after 2 weeks on holiday. Even though we've got this strange lockdown mentality still, it was quite odd to be away on holiday. And also, it's my 24th wedding anniversary as well. So few things happening all at the same time. But let's talk about Kubernetes, and we've had some interesting conversations over the last 3 or 4 months with people who'd gone down the route of developing container-based workloads, and then when they started to deploy them out into production, were a little bit challenged. And there's been a number of things that's challenged them. What I'd like to do is just go through some of those key areas and then talk about how they could actually deliver a better environment using Diamanti as a technology. So first thing is around stability, and a lot of people, if they're going to go down the Kubernetes route, may start doing their development activity either on local laptops using something like Docker, and they can also go down the route of using one of the cloud platforms, GP or the equivalents on AWS and Azure. That's quite straightforward in a small protected environment, and it doesn't really matter too much around performance when you're actually doing that development phase. But when you move into production, the next challenge is having that level of stability with it. And a lot of organizations, if they're trying to do this locally rather than continue to run in production in that cloud environment, have had some issues. And a couple of ways you could do this is go down the route of implementing some kind of OpenStack or open source platform, or you could go down the route of implementing a bare metal Kubernetes environment, utilizing one Linux distribution and then building on top of that. A number of organizations have gone down the route and then have been challenged. And the challenges come in that initial stability to ensure they're getting the right levels of performance out of the infrastructure. Some of the other areas they're struggling is where they can actually separate the environment between the different groups that need access to it to ensure that people don't have God power. So being able to effectively tear down the complete environment, every single container with a single transaction through the CLI. And that can be a real risk for a lot of organizations, especially if your naming convention is quite close between the actual workload. Can end up shutting down a production environment when you think you're actually shutting down one of the actual test and dev environments. A further thing I think people are struggling with is security. It's not just security for the individuals who are accessing the system, it's securing the actual workloads themselves, the data that those workloads are accessing, especially if you're looking at things like stateful applications using databases or other data sources that actually needs to be persistent. There's a lot of organizations are challenged there. How do they actually protect that data, and not only from loss by someone hacking into that information, but also accidental loss of that information? How do you snapshot it and protect it? How do you replicate it somewhere else if you want to have it available? And if you're looking to go down the route of a high availability cluster, how do you ensure that those snapshots and replication is quick enough so that you can actually have cross-cluster high availability, between two data rooms, same campus, or two data centers have got high-speed connected between them in the same geographic region. I think there are other areas as well. Is on that stateful side of things, how do you ensure that that data is running and is actually available fairly quickly? Because performance within a storage environment works really well in a traditional enterprise platform when using something like some of the standard hypervisor technology like VMware, or if you're using some like Hyper-V to be able to run it with an enterprise storage cluster behind it, when you're starting to run across into this container environment, again, it can be a challenge to ensure that the infrastructure you've got gives you that level of performance, not at just the compute side, but also at the storage piece, because you've got to have fast access to that data to be able to then present information or utilize that information quickly. So, a number of issues that a lot of organizations have. So, people have tried, using their own, engineering resources to build out a platform using bare metal, utilizing some of the open source platform. And when they get to the point where they've tried it for a little while and it's not worked, they haven't been able to get the level of stability or performance, they're having issues around controlling the environment, and many people then go back to what they feel comfortable with and they go back to using a hypervisor. A couple of issues there. If you go down the route back to, say, VMware, you've got the licensing costs. And again, licensing costs have changed, and we're now looking at it by core because a lot of organizations are multi-socket but very large number of cores. So the licensing costs are increasing in that space. So a lot of people are having issues with the cost of licensing their infrastructure. But on top of that, you lose a percentage of the performance. So part of it is run just to actually run the virtual machines, in which virtual machines you're running then your effective platform. So commonly you'll be running some form of either Docker or other container environment within a Linux platform. So each time you're losing some of that resource within the physical. Yeah, so it becomes a bit of a challenge. And if you've got full rights as a VMware administrator, again, you can actually tear down anything that's in there. And if you're not careful, it quite easily have people tearing down production environments when they think they're tearing down test and dev environments. A lot of organizations are also trying to automate the complete end-to-end process. They're using things like Ansible and Terraform to build environments, load up the data, snapshot it, and build it out. And again, a lot of these organizations are challenged using hypervisors to actually get the level of performance from them in this fully automated. So let's consider what you can do within a Diamanti environment. So Diamanti gives you 3 levels. So first of all, it's giving you a physical layer that you can actually run workloads upon. So you're getting a 1U rack mounts platform. These are manufactured by people like Lenovo, Dell, HP. And you can then put in there the amount of memory and CPU you like. And they built out with NVMe storage side of things. So you've got extremely fast storage. If you look at what the cloud providers are doing, they're trying to offload a lot of the network and storage away from the standard compute. So Diamanti utilizes 2 PCIe cards that actually takes away the workload from the actual compute platform for that network and that storage piece. But it also gives you a second thing, it isolates them from the compute environment. Well, it's one of the issues when you start building out your infrastructure. How do you isolate those workloads from the outside world? And if you go down the traditional route, sometimes it's quite a challenge to build out your distributed switch network, virtual hypervisor, then the virtual machines on top of that, and then the containers within those container hosts to be able to separate it out. Using the Diamanti platform, it's quite straightforward. You have effectively pseudo network internally within that Kubernetes environment, and then you can then allow access from the outside world with specific network addresses and address schemes to particular containers in there. While a lot of the other containers just communicate using that private network. Quite straightforward to do that network separation between the workloads environment. And you can do the same thing across cluster as well, because the clusters understand each other. You can actually have a protected network within the clusters as well. Then again, separate your outside world access to it. A good example of it is when using something like Elasticsearch. You don't really want all of the containers having external access. Really, the ones that are ingesting data that you have external access to. If you can protect the rest, It reduces the actual attack surface from a security perspective and ensures that you have a much more stable environment. But also you get above that in Spectre, especially with Spectre 3, which is the latest version, which is due to be released, I believe, this week or next. You're getting something else. So you're actually getting the ability to run stateful applications. So instead of just allowing us access to the containers themselves and running a workload within them, which is something that a lot of people are utilizing Kubernetes and containers for, because it gives you the ability to develop an application workload once and deploy it anywhere. As long as it's a standard container environment, you can actually run that workload. You don't have to recode it, migrate it, or a new environment. It will just work. But what they're also looking at now is that stateful side. How do you create a PV? How do you create a PV claim? And you allow that then to have some data within it, whether that's a database or some other type of data that you can access the application. What Diamanti allows you to do is actually generate those and have multiple storage types. And you can do 2 or 3 different things. One is around the performance. You can specify performance tiers. So internally, you can have a high performance tier using NVMe. You can have a standard performance tier which uses NVMe but best efforts against that rather than highest level. And then finally, what you can do is use a third-party storage platform. And you can offload that storage for, say, archive to a third-party environment for old data. You can do that quite easily within the standard settings within Kubernetes to do that. On top of that, you might want to encrypt the data. So things like data encryption at the container level is really important for lots of organizations, especially people that are in the finance area and they want to protect individual containers separately. So what you can do is actually set encryption against those storage classes as well. So it's not only set by the actual performance level, but also you can specify whether the data is encrypted. So really secures the actual data side of things. And on top of that, then we can then snapshot and replicate that data. So we created our PV, we created a level of encryption and performance characteristics for it, and then we can specify how often and how regular the replication is between those PVs. So it might be we're running cluster across 2 sets of Diamanti clusters, and what we're trying to do is ensure that the data is replicated live. And then what we can do is have 2 sets of containers running as 2 separate pods or pod replicas even, and we've got that HA availability across it. So protected it, we've secured it, we've made it stable, and what we can do using RBAC, we can specify who has access, which sets of containers, and we can even split it up by department, create different tenancies and then projects with tenancy. With those RBAC rules, we can specify if someone's got administrative rules within a specific project, within a specific tenant and the project within it, and also from the top level across all of the environment. And we can give them full admin rights, we can give them read-write access to specific things, or we can give them just view only. So we can limit what people can see, how they can access the infrastructure. But as it's a full container set from a storage and a network perspective with all the standard API calls, we can actually do everything we would normally do from Kubernetes perspective within that environment. So again, we can use scripting like Ansible, Terraform to actually build out the environment and fire up the containers. We can use Helm charts and things how we would normal. We can use YAML as we would normal, and we can actually build out the infrastructure. We can then use scripts to automate the process of increasing or reducing the amount of capacity based on what we can see happening within those container loads. As we see the workload increasing, we can spawn more containers. If we can see the actual workload reducing, we can down. And again, we can do similar things with the data behind it. So system volumes are protected, but also available for those containers. So there are a lot of things that we can do in that space that helps us create that better stability, ensure security, ensure that we're actually splitting out more granularly the actual access and admin rights to that environment. But also, if we move into a true DevOps environment, we want to be able to do this in such a way as the actual development people can access it and manage it themselves with the ability to self-service. So instead of having to rely on IT to build out their container clusters and load in their code, you can actually do this directly with the RBAC capabilities, so that the DevOps guys can build out their own infrastructure for development and test, and then you can stage that into production. And a part of that ability to snapshot data within those PVs allows us then to snapshot data from a production or from a test and dev environment and replicate it back to either whichever. So useful when we're doing testing to use live production data to ensure that the data is correctly testing phase, and then when we roll into production, be able to take a snapshot of that data, put it into a PV, and give it access to the new version of the application set, so we can roll it out. So lots of things that we can do with Diamanti that helps us with this environment to ensure, let's say, stability, security, performance. And because of this new version 3 of Spectrum, this is not just in the container workloads, but actually within a Diamanti cluster, so on physical bare metal infrastructure deployed on site. It can also be within, say, Azure environment, and we can replicate workloads to and from without having to migrate them, because code itself is the same. It's running in a container environment in the same way. What we're going to do is just replicate those PVs between the two. So we've got the data there as persistent, stateful applications without any code changes, and move them to and from this environment. So it gives a lot more flexibility in the way that we, one, develop, deploy into production, and operate. I think this is going to be really important for a lot of organizations that want a bit more control over how they deploy their workloads, but also the ability to reduce the amount of hardware infrastructure to utilize for their production environment, because the hypervisor does take away quite a large amount when you're stepping up from just the ESX host environment. Then you've got to take account of the next layer of container hosts that are consuming resources as well. By going to a fully bare metal environment, you're going to get reduced amount of resource loss for those containers. So it's going to help a dramatic amount in the amount of infrastructure, giving you a lot more lower latency, give you a much better response for customers. I think that's all I wanted to cover today. And so we're going to get back to doing some more interviews. We've got Eric Yan and Boris and Frieza we've done interviews with previously. What we're going to try and do is get more people to talk about their experiences of using Diamanti as they go forward, so you can actually see benefits that people get from the actual infrastructure itself, and also proving to you that we can actually have an environment spun up within 15 minutes ready to deploy workload. Because I think that's a challenge as well for a lot of organizations. It can take 6 to 12 months just to get the environment ready and start to. With this, we can do it in 15 minutes once we've actually racked and powered and cabled the infrastructure. It's so quick. We're actually going to do the same kind of stuff within our own data center. So we're going to set up a Diamanti cluster in our data center. What we'll do is video that as well from the beginning to end. So show you racking and powering and cabling that infrastructure to the point where we actually have our first production workload running in that. Show you the time it takes and the steps we take to do that. Again, it's easier than traditional environment hypervisor container house, or trying to build your own and get your developers to go through the process of building out an infrastructure. So hopefully that's been of use to you today. I look forward to seeing you again tomorrow, because it's our regular Tintery Tuesday tomorrow. We will talk about more what we do within the Tintery environment, and we're going to focus at the moment around this new release that gives us much more tools around SQL Server. So we're going to go into that in more depth, talk about how the SMB3 access is done, from your either physical workloads or your virtual workloads to TinTree server, and see how you get some real benefit in that SQL. Thank you very much for joining me today. Hopefully you get a chance to join me tomorrow at 3 o'clock again, TinTree Tuesday, and I shall see you then.